Hi, thanks for attending this talk. We are here today to talk about compliance in Kubernetes, how to enforce and visualize. First, let me introduce myself. I'm Guilherme Vanz. I'm software engineer working at SUSE, currently working in container technologies. Before we start to discuss about Kubernetes stuff, let's do a brief definition of compliance. If you read the definition in the dictionary, you may see something like when people obey an order, rule, or request. So bringing that definition to our context, we may think of that we can apply compliance in many layers of the cloud native application, cloud native stack. Like we can define compliance for the network layer, define how the network should behave and what's the organization, or up to the workload layer. Then we in this layer we can think of maybe we need a set of mandatory labels or annotations to give more additional information about the resources and the apps running in the cluster. We may say that our containers cannot share host namespaces, or they cannot run as root, or they cannot run as privileged containers, right? And maybe we also want to enforce that uh, all the container images run in our cluster should be signed by a trusted entity, like so we can ensure a secure supply chain, right? Um, Among other things. So we can say that a compliance rule set is everything that keeps our cluster consistent, secure, and easy to evolve. But how can I enforce a compliance in a Kubernetes cluster? Well, if you are using already the deprecated PSPs, we can say that you are kind of using compliance because you can define that you block privileged containers, you cannot share host namespaces, this kind of thing, or you may think of you start to think of using the built-in pod security controller, but for today, we will talk policy engines. And in this space, we have a bunch of options like the kernel, kubewarden, OPA, but I will focus on kubewarden during this presentation because it's the current project that I'm working on. Okay, so how can I use kubewarden to enforce compliance, right? Well, as I said before, Kubernetes is a policy engine and it works as a dynamic admission controller, which means that um, the, the Kubernetes has the power of accepting or rejecting resources in the cluster. Because Kubernetes API will ask the policy engine, the Kubernetes policy engine, to see if they can run a resource or not. And Kubernetes will give a response: yes, you can run it, you cannot run it, or yes, you can run it, but I will change some default configurations, some configurations to make that compliant with our policies, right? So, and these policies that are run by Kubernetes is just regular programs like written in Rust, Go, Swift, .NET, and Rigo, which is the language used by OPA, and they are compiled into WebAssembly modules. And these WebAssembly modules is what is run by the policy engine. So it's quite flexible. The policy is quite flexible. You can do whatever you want, whatever you do in a regular Rust program, you can do with the policy and compile it into a WebAssembly. And and of course, we can say that Kubernetes can allows the cluster administrators to define the policies as code, right? Which is pretty cool. But how that translate to the user that is interacting with the cluster? Well, when you want to deploy something, if everything is fine, you are following all the rules that are defined by the operators, the resource is just created. But if you try to deploy something which is breaking, then some policy, you get an error, which means that yes, as an example, in the second line, second kubectl apply, can see that your pod has been rejected because it's trying to share a host IPC host namespace, which is not allowed by the policy running in this cluster. Okay, and the policies can be applied in the cluster wide or just in specific namespaces, and they have two modes, which means that you can have a policy which in protect there is two modes, protected and monitor mode. Which protect mode, it says define that if the policy reject the resource that you're trying to create, you will not allow it. You cannot deploy it. But if it's in monitor mode, if the policy reject, the resource is still created because you are not enforcing it, the policy in the cluster. So there is this kind of different um, modes we can play with to before enforce some new policy that your organization would like to apply in your cluster. But what can I enforce already with Kubernetes? Well, we have a bunch of policies in the Artifact Hub. As a CSF sandbox project, our policies are in the Artifact Hub. And and for example, if you are using deprecated PSPs, you can already migrate to Kubernetes because we have 100% coverage of PSPs. And we even have a script to help you on that, at the migration process. And everything is there. We can search it and use it. And we also have a policy to enforce that you just run container image from trusted entities, and you can also write your own policies depending of the compliance rules from your organizations. You can run the write in your own policies and deploy it, which is kind of cool. And all the policies evaluations are store the data generated by policy evaluations, like if the request is accepted or not, which policy reject or accept the request, if the request is mutated or not. Everything useful about the resource that you are trying to apply is stored in a Prometheus metrics. And then we can start to query these metrics to extract information about your cluster behavior, like how many rejections I get, what is the policy which rejects more, why that's happening. Then you can start to think of alerts that let you know when something wrong is happening, and everything that you need can be found in the metric. And for help our user in this, we have a basic Grafana dashboard which extracts basic information about from these metrics and shows to you. So you can get that Grafana dashboard and extend it for your own needs. And it's all public and available and ready to use, so you can use it right away. But let's take a look in how that works in a real Kubernetes cluster in the demo. In our demo, to save time, I've already have a Kubernetes cluster with Kubernetes stack installed and some policies applied and running. The policy that we are running is 3, and they represent our pretty basic compliance rules that we want to apply, which are the pods cannot share namespace with the host machine, pods cannot run privileged container, and pods cannot run containers with root user. The definition of the pods it can be easily checked and understand. All of them are cluster-wide policies, and all of them are running in monitor mode, which means that they are applying the whole cluster and they are running in monitor mode. Which monitor mode is the policy is when the policy runs the evaluation, but the result of the evaluation is not used. And in this mode, all the admission requests are accepted by default. And this is useful if you want to deploy a pod, deploy a policy and verify if it runs fine, if it is too disruptive in the cluster, and this kind of thing that before you start to enforce it. Because when you enforce it, if the request is rejected, the resource cannot be created in the cluster. So that's why you are using monitor mode in the whole in the three policies, and but we will change that after to see how it works. Um, the module is the URL of the container containing the WebAssembly module. All of them are in the GitHub if you want it. The namespace selector is a default value for is using a default value from the Kubernetes Helm charts, which says to Kubernetes to ignore some pretty common control planes namespaces. The rules down here is tells Kubernetes Kubernetes which resources you would like to validate or mutate depending of the policy. In this case, actually on all of the policies here, we are just evaluating the pod resource, okay, and the creation and update operations. The mutative flag tells Kubernetes that these policies will not change the admission request, because some policies can, instead of rejecting the resource, they can adapt the admission request to attend the rules and then accept it. So the admission resource will be the resource will be applied in the cluster. Okay. The second policy is the policy which prevents users from running pods with sharing host namespaces. In this case, everything is the same as the previous policy, except for the um, settings, which now we have something to how to configure the policy, because you can enable one namespace, disable another, but in this example we disable everything. Okay, and it's running in monitor, and it cannot mutate resources. The last policy is a little bit different. Is still running in monitor mode, but here we can mutate the admission requests are generated by a creation of a resource, because this is a replacement for PSPs, and in the PSPs, when for some specific configurations, when the user does not provide the expected configuration, the policy will change the resource. So in this example, when the user does not define a configuration, a security configuration in the security context to tell Kubelet to not allow root user, the policy will add that configuration for you. So even if the user forgot or didn't define, the policy will mutate the admission request and allow the deployment of the resource in the cluster. So that's the definition of the three policies that we are using. So I've running I before the demo, I started to run some scripts to generate data for us to take a look in the dashboards and metrics. But I will show you now that even if the policy does not allow some pod configuration, we can run it because it's monitor mode. So let's see the this pod which violates the hostname sharing compliance rule, and we can still run it. Let's do it. Fly f run hostname spot. So let's wait a little bit to deploy it, and it's created. But it cannot be created because it's violate our compliance. So we will see soon how fix that. Let's delete it just to clean the environment. Cool, is deleted. So now let's take a look in the Grafana dashboard to see some fields and labels of um, our metric. Let me transition to the Grafana, and here we are in the Explorer section of Grafana UI, and we will just see which labels each um, time series have that we can use for plotting stuff. So the query is running. It's quite a little bit slow, but okay. So the important field for us now is some of the labels in this time series, like the accepted. The accepted tells you if the policy allows this resource to be created or not. Okay. So in this example, all of the time series show that the resource will be rejected. Okay, so the mutate label tells you, yeah, I accepted this resource, but I will change it to ensure that some rules are followed, like the user group that I just mentioned. Okay, the namespace is the namespace running the policy Kubernetes policy engine. The pod is the pod of the policy engine. The policy mode is the mode of the policy which generates this time series. In this case, we see that we are running this. There is some metrics here which shows you that um, the policy was running in protect mode, which means that this time series shows a rejection in the deployment because the accepted is false and the policy mode is in protect. Okay, the policy name show you which policy reject or accept or mutate the resource represented in this time series in the metric. Resource kind shows you which kind of the resource was under evaluation. The resource namespace show you the namespace of the resource that you're trying to create or update depending on the configuration. Okay, and the resource request operation and service is the operation that triggers the policy evaluation. Okay, so let's take a look in the Grafana dashboard to see how we can use that. So here I've imported the basic Grafana dashboard available in our repositories, and I added some other panels just to see how we can use that for monitor compliance. Okay, so for instance, in this panel here we can see that most of our rejections come from the policy about the preventing pods of sharing host namespaces to 62%, and the remaining one is from the no privilege pod. So we can see that most of our users, cluster users, are violating this in the universe of the rejections. Most of them are related to the host namespace sharing. So in here we can see. Okay, let's take a look in which namespace is rejecting more resources, right? So here we consider that the namespace is a team, for example. So we can see that the team A and team B have pretty similar rejection rate over time. So, but we don't have information about um, which policy they are rejecting, right? So if you go there in the left, in the second row in the left, we can see uh, the rate of rejected request by policy. So we can see over time which policy is rejecting more um, resources, which is in this case most of the host sharing namespace is rejecting more, which is expected because we saw the line above that 63% come from this policy, which makes sense. But the rate allows you to see the trend, right, over time, right? And the pie chart is just this sum of everything. But yeah, we can still see that there is host namespace policy is rejecting more, but who is generating that? Which team, right? So if you go in the next um, chart, we can see that the rate of the rejected request grouped by namespace and policy, which means that we can see now which team is rejecting which by the team by each team what about which team is rejecting which more policy, which in this case we can see that the default the team A has more rejections in the hostname sharing namespace. The and the team B, the most rejected policy is privilege. The policy rejecting more resources from team B is no privilege report. So we can now approach the team and say, hey, I noticed that you are having some issues with host namespace sharing. Let's fix that, right? And down here we can see that among the universe of all requests processed by Kubernetes, most of them actually accepted. Just a percent of them are rejected. So all of this information above is regarding to this line here in the bottom. Okay, so but considering the accepted requests, how many are mutated? Like this tells you that the users are not actually the resources that running in the cluster are following your compliance rules, but the compliance rule needs to adapt the resource to make that compliant. So we can see that and most of your accepted are mutated. So the the policy need to fix the deployment before accepting the request. So yeah, that's nice information that we can extract. And remember, these are running in monitor mode. Most of the actually most of the time series are running in monitor mode. So and we are not filtered by policy mode, which means that we cannot differentiate which graphic which rejected are actually rejecting resources in the cluster or is just evaluation in a more policy in monitor mode. Okay, so let's change that. Let's suppose that we are fine now. We can if we start to enforce everything. How we can do that? Actually, it's pretty simple. We just need to update the policy mode to protect and wait the re deploy of the policies, and we are done. Now your policy cannot your resources cannot run anymore without following your compliance rule. So let's do that. Let's change the policy mode. Let me transitioning to terminal again, and now we need to update our policy definition just by changing mode protect protect protect. Cool. Let's save it and let's apply it. Cool. The policies are reconfigured. So now we can follow the update. So yeah, but because now we trigger the Kubernetes controller event, which will redeploy the policy server with the latest changes in the policies, migrating from monitor mode to protect mode. After that, when you try to run a policy, a resource, sorry, when you try to deploy a resource which violate your rules, you'll be rejected, and you need to fix your deployment before sending it to the cluster. So after some time waiting for the for deployment, we can see that the policy server are up and running again, and we can try to apply some resource which will break our compliance. So now we can see that the admission webhook, which is the cluster-wide no-host namespace sharing policy, is denying it because the policy has IPC enabled, but it's not allowed. So that's how protect mode works. It prevents you to running. But if you run another policy, like sorry, another pod, like this one, which is pretty simple, but it does not define the security context to prevent non-user non to prevent user of running as root. It, instead of rejecting it, it will be mutated. So we still can apply this resource in the cluster. So it's there. Yeah, so guys, that's the demo. So thank you guys, that's all I have. If you are interested in Kubernetes or something related to our project, please join our channels in the Kubernetes Slack. Feel free to ask questions, ask for features. We are there to help you. And if you want to talk with me, please go to my website, follow me on GitHub, or reach me out in the Twitter. Thank you. Bye bye.